Hello calculus students, welcome to the continuing series of videos on calculating exact area under a curve or finding the exact definite integral. We're not there yet. We started out with a very rudimentary example and we're going to extend the process a little bit more. So now we're going to calculate this sum here, but in the last video we did it with 5 rectangles. Here we are going to do this with 20 rectangles. So I'm going to write out the sum first, but let's think about this for a minute. The base of each rectangle, the width of each rectangle, is going to equal 7 minus 2, because that's how long this line segment is right here that forms all of the bases, divided by 20, because we need to cut them up into 20 rectangles of equal base. So this is going to be 7 minus 2 is 5 over 20 is 5/20 or 1/4. Okay, so imagine cutting this up into 20 little pieces. So when we go to calculate the area, all of our rectangle is going to have a base of 1/4. And then the sum that we're going to calculate, the first sum is going to be f of 2 plus 1/4, then 2 1/2. So we're going to go along here, 2 1/4, 2 1/2, and so on, all the way until we get up to 7. So this is f of 2 plus 2 times a fourth plus f of 2 plus 3 times, or I should write it this way, 1/4 times 2, and then 1/4 times 3. And I'm going to repeat this 20 times until I get to f of 2 plus 1/4 times 20. Okay. So you can now hopefully see why we did some of the weird stuff that we did earlier before, where we try to express all of these in kind of like overkill. But what we're trying to do there is understand where these numbers really come from and what these numbers truly mean. Okay. So I'm just going to slide this up a little bit here so that we can fit it all onto the same page. So now if you think about what we had going on before, this 1/4 again is the width of each rectangle. These 2's are going to stay the same. This is the left endpoint. Oh, I forgot to multiply by a 1 here. So I will change this. This is 2 plus 1 times 1/4. Okay. And it's kind of the same as what we had going on before. Oh, this should be 1/4 times 1. I don't know what I'm thinking here. This is 1/4 times 1. Okay. So all of these 1/4 are the same. Okay. And then the numbers that are the only numbers that are really changing here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 20. And those are your iterators. So we can write that the sum here is going to equal 7 minus 2 over 20 times the summation of I equals 1 to 20, f of 2 plus 1/4 I. Okay. So we're going to be able to write this answer as a summation. And again, f is x squared, and I'm not really worried about that at this point. I'm just more worried about being able to express things in summation notation. Okay. So if we take it one more step further, this is a bit of overkill now, but hopefully we can figure out that the width is going to be 7 minus 2 over 1,000. So that's 5 over 1,000, or 1 over 200. Okay. So let's see if we can jump straight to the final notation, summation here. So this total answer R of 1,000 is going to be 1 over 200 plus, not plus, I'm sorry, times the sum from I equals 1 to 1,000 of f of 2, because 2 here is our left endpoint, plus 1 over 200 times I, okay, where I is our iterator. So I is going to count from 1, 2, 3 all the way up to 1,000. Okay. So there we go. You have another summation. So all of this is being done here just for us to do some good practice. I'm going to end this video, and we will pick this up where we take it to the most extreme that we can take it, which is infinity.